Welcome everybody to our new features talk for Oracle Data Pump. Now, just to introduce myself very briefly, I'm Roy Swonger, Vice President for Database Upgrade, Patching, and Utilities at Oracle. And the utilities is where Data Pump falls into the mix there. So if you don't know, let's see, there it is. Data Pump is there to help you move data between out of into Oracle databases. So this starts with 21C new features, and I realize that most people are not going to be going to 21C, but the reason we like to keep this talk as current as possible is that first of all, you may have noticed that many 21C features or new features are getting backported into 19. So some of these will get backported over time. But also it pays to know what's available. Some of these will get into the cloud before they get to on-premises. And as we go through this talk, I will work my way backwards and try to cover 19C new features as well. And that will have a lot of value to people who are going up to 19 for the first time. And at the end of this talk, I'll talk about some very important patches that you want to get. So we've categorized these new features into groups, and I'd first like to talk about the features that were really developed with cloud in mind, but it's important to note that these are also very useful on premises. So here's the list, and we'll go through each one of these. You may notice that I'm going to go through these slides fairly quickly. I will try not to speak too quickly, but these are also going to be a good reference. You will be able to download all of these slides as soon as we get them onto Mike Dietrich's blog. So the first new feature that's available starting in 21C is the ability to export directly into Cloud Object Store, specifically the Oracle Cloud Object Store. We are looking at what it takes to go into other clouds like S3, like Azure. But what it means is that we can now use the credential parameter to specify cloud credentials for an object store bucket, and the dump file can now be a URI for the cloud. So here's an example of that. So in this case, what you can see is that the dump file parameter is not a traditional file location, but it is a URI for a cloud object storage resource, a bucket, and a specific file name. And then the credential will be the credentials that you have already created in your database. So the credential, if you supply the credential parameter, it will expect that the dump file is a cloud URI dump file. So don't go specifying a credential parameter and then using some sort of local file directory as the output. It will have to go to the Cloud Object Store. The default directory parameter is kind of useful though, because that is where your log file will go. And this is a time when we will differentiate between the directory parameter and default directory, because in many of the cloud services, you don't have access to the local disk where you are. So there's kind of a fork between going your log file to one direction and your dump files to another. Another thing that has been added, import from the object store for autonomous database. We were actually added this back in 19C for autonomous database. Starting with 21, that will be available for any database, including on-premises. So this is very useful for migrating from the cloud back to on-premises, for example. But what's important here, especially, is the differences between our autonomous services that have shared infrastructure and dedicated infrastructure. So what we've got here is color coding. So apologies for anybody who is colorblind, but hopefully you can still see the difference. That red parameters are only for shared infrastructure, blue is for dedicated, and black parameters, regular text, is for both. So for example, in ADW, ATP, and shared infrastructure, you can specify a directory object. What they do is they use DBFS under the covers to allocate a directory using the same path that you would specify. So they've kind of come up with a way of faking a directory by putting it in DBFS in your tenancy. Then we have the credential and dump file that I just showed you. So we're going to be importing from the credential and from that dump file location. And the encryption password prompt, again, only available on ATP and shared infrastructure. On dedicated infrastructure, you would use your wallets, mandatory there. And then a couple of other differences on shared infrastructure. We would like you to exclude index types where possible. In general, when you're importing into Autonomous database, you exclude this set of objects and let Autonomous handle the tuning, the building of indexes and partitioning and so on. But then also specific to dedicated infrastructure, we'd like you to say just no log file. Don't produce a log file when going to dedicated infrastructure at this time. What you would be better off doing to capture your log output is to redirect the output to a file from your terminal. And as it mentions here in the pro tip, this is always a moving target. So we're watching this today, towards the end of October 2021, the next cloud update may actually change some of this guidance. So it's always a good idea to go to the specific documentation for the cloud service, because restrictions would get relaxed, features get added, and so on. So here's just a demonstration of exporting to the object store, a very quick one. And what we do is we connect to our source database on premises, and we'll set it up by creating a user and creating credentials to access our object store bucket, creating a dummy table here with some rows in it. And then we export to the object store. As you can see, we've got our credential parameter and the object store URI as the destination. So other than that, it looks like a regular export. We have exported successfully to the object store. We can then connect to our cloud instance. In this case, I believe it's ATPD. And we're using the easy connect syntax for SQL+. We create the credential in ATPD for the object store, and then we can list we can import, and then we'll list the table just to make sure that everything got there correctly. So this is pretty quick because it's just a 20-row table. Of course, it is a schema import, but the schema at this point only has one table in it, and it's a very small one, which is healthy for your typical demo. Okay, so that shows you that we've confirmed the row count and that our import succeeded. So that's pretty basic stuff. Now, we can also, if you don't want to go through an object store, when you're migrating to a cloud database, it's good to remember that you can use a database link to move directly into a cloud database. This isn't actually, well, this is a 19C capability because that's when Autonomous databases were created, was really with 19C. And this is for especially ATP dedicated will support these DB links. There's work going on right now for the shared infrastructure to accept database links of all sorts. There are certain types that it can use right now, and I'm not going to try to list them. But basically, the idea with this is, as you'll see in this demo, it's very similar. What we're going to do is connect to the on-premises database and set up our user, create a table, in this case with another 20 rows in it. And then we will connect to the ATP instance in the cloud and create a database link that points to our on-premises database. Now, that part is the hard part for any user. Whether you can create a database link that goes from the cloud back to the on-premises database is going to be a question of your firewall, your connectivity. Do you have VPN set up to go to, or VCN set up to go to the cloud or not? So I'm not going to claim that you can do everything literally here, because you might have a bastion host in the way. You might have other ways that you have to connect from the cloud back on premises. But the point is, get that link created, and then you can import directly from your on-premises database into the cloud, or vice versa. So that is a really useful technique, especially for smaller databases, because in those cases, you're not going to be as worried about the network latency. If you're dealing with even hundreds of megabytes, you can do that over a typical network connection in a pretty reasonable time. Once you get into lots of gigabytes, or I would say more than say 100 gig, then you're probably going to want to export to a file and either transfer it to the object store and import there, or if you're, of course, going from 21C, export directly to the object store. Okay, so those are pretty cloud specific, although you could make use of object store access in even for on-premises databases. If you don't have extra disk around, you could export to the object store and then import, but that would be pretty high latency. Now let's talk about some features that are much more applicable on premises. And the first of these is checksumming of dump files. We added checksumming with 21C because, especially for cloud migrations, a lot of customers are running into issues where transferring files over the network, you just run into a bit getting flipped here or there. We used to call it the network gremlins, or the line eater back in the old Usenet days, that would consume the first first line of a Usenet post, for example. But the idea is that by putting checksum in the dump file, you can validate that your dump files have arrived at the object store or arrived at your remote location intact, basically. And it's really not meant so much to guard against malicious changes as it is accidental changes, but there is some degree of validating even against malicious changes or kind of nasty payloads being put into dump files. So what we have here is we have the checksum and checksum algorithms as parameters, and you can determine whether or not to verify a checksum when you import. So first of all, the checksum defaults to no, so you do have to specifically say that you want a checksum on your dump files. And the reason for that is simple. It does take a little time to compute a checksum for each file in a dump file set. And what we do is that checksum lives at the tail end of the dump file for each dump file. So the bigger your database, the longer it takes to create the checksums or to validate the checksums when you import. You can choose what checksum algorithm to use. It will default to SHA 256. And then on import, if you have a checksum as part of the dump file set, the default will be that we will validate it. If you've already validated the checksum and you verified that the dump files are good, then you could say verify checksum equals no. And the way that you would verify the checksum without importing is by saying verify checksum equals yes. So you could make it a two-step process, and that way you're not taking time during the import to verify the checksums. If you've done that in advance, you don't have to do it as part of the import. So I think that's a pretty generally useful capability added in 21. Another thing that we added in 21, and this is one of our longest standing requests for Data Pump. It's the ability to have include and exclude of objects in the same operation. So if you go back all the way to original export import, you had the ability there, you didn't have the general include and exclude filters. You just had a few of them, like you could say constraints equals yes or no, indexes yes or no, triggers yes or no. But you could mix and match those. You could say constraints yes, triggers no, for example. And you couldn't do that with Data Pump because the include and exclude, while they're very powerful, up until now, they couldn't be mixed in the same command. And now you can do that starting with 21. You could do what we have here, include a table, but exclude statistics, for example. And the specific way this works is that we start with the exclude or the include. So that means with include, you're saying, I only want this type of object. So with table, when we say, and I'll give you an example here. If you said include equals table, we would get everything that was a table definition and everything related to tables in the object path here. So you see we're getting tables, we're getting table comments and the indexes on the tables, the table data, the table statistics, and so on. If you add exclude statistics, then those two rows wouldn't show up in your log file. We would not get the table stats as part of that import. So this is a nice way to be able to combine recommendations. For example, we often will recommend that you exclude statistics from an export or import just because statistics are relatively slow to process. But then if you only want to get a subset of your database and you're doing an include, then you would have to do, like in 19C, you would do an include on your export and then an exclude on your import to have that same effect. So I think this is a really useful feature. And finally, for 21, a useful feature, but probably not as broadly useful, is that we've added control over the index compression clause for import. We've always had this, well, not always, we've had this for data pump since 11.1 when compression, OLTP compression was added to the database. But now you can also control index compression in addition to data compression. So this can be useful if you're moving to a new environment where maybe you have compression licensed, like in the cloud or in a new server, maybe you've got compression on your new server and you want to take advantage of it. Or if you just want to change the way your indexes are compressed because there's a new type of index compression available in 19 or in 21, for example. So this lets you change that index compression clause on the fly during import. We'll change it from whatever it was in the dump file to whatever you want in the new database. Oh, also another new feature, I forgot that we had put this in, and this can be very useful in a variety of situations, but specifically this was put in for our autonomous database. And this gives you a sense of how things that we add for our cloud environments often have a lot of value on premises. And this is basically, we added the ability to have a wildcard for remap table spaces. So why did we do this? Well, in autonomous shared infrastructure, you get one table space for your user data, and that's the data table space. So if you're migrating an existing database up into autonomous, you would typically want to remap all of your user table spaces to data. And that way, all of the files, whether they were in your users, your application, whatever table space, it would end up in the big file data table space. And on autonomous dedicated, you do have the ability to have multiple table spaces, but only up to about 24 of them. So I've worked with customers who have had hundreds or even thousands of table spaces. And again, you're consolidating into a smaller number of table spaces. And this lets you do that easily. You could remap with a wildcard and just say, take all of my user table spaces and put them in data, and I don't have to know what my user table spaces are. It keeps my command shorter, easier to manage. So this table space transform parameter is actually similar to this. If you take remap table space and remap everything to data in ATP shared, well, data is your default table space in that case. And that's kind of the shorthand here. This is a new transform parameter in 21, where we just say, if we want to, with using this parameter, you would transform all your table spaces to whatever the default is in the new database. So if you created a new database and you said my default table space is TBS_1, you could remap everything from an import into that table space with just a very quick transform equals table space yes. So all of those features were developed to help with migration to our cloud. And you can probably see how it helps in those cases, but how many of them are useful on premises. We've also been putting a lot of work into transportable table spaces over the last few releases. So I'd like to talk about some of the features that have gone in there. One is that we can now export and import metadata in parallel starting in 21. And this is a big change for transportable table spaces. It used to be, we introduced parallel metadata export back in 12.2. but that was for dump file jobs, not for network mode or transportable. We can now do parallel metadata export, it should say and import here, for transportable jobs. And this is very important for metadata heavy applications like eBusiness Suite, SAP, any enterprise applications. So it's very simple. It's basically, even if you're using transportable table spaces or full transportable, the parallel keyword will help speed up your metadata. Another thing that we've done is we've made our transportable table space jobs, both export and import, restartable. So this means that if you run out of disk space, or if for some reason your job is killed, or you decide you have to pause it because there's other things going on in the system, you can restart the job without starting over from the beginning. And that's really important for transportable table spaces on export, because generally when you're exporting transportable table spaces, your table spaces have to be read-only. And the shorter period we can keep them read-only, the better, right? So by doing this, by making these restartable, it will help reduce the possibility of extended downtime if you have to restart a job. We've got some new features in SQL Loader in 21C. One is just support for the native JSON data type. So if you haven't looked at 21 extensively, 21C introduces the new binary JSON data type as a first-class data type in the database. We had support for JSON in 19C, and that was JSON generally stored as a CLOB, and there's a lot of robust support there where you can access specific JSON tags within a CLOB, you can query off it and so on. But for performance purposes, we then implemented a binary JSON storage, which will be much faster when you get to 21C. So we'll be able to load that. And the nice thing is you'll be able to load it and do conversions. So if you want to create a database in 21, let's say you have the current CLOB storage in 19, you want to go into 21, convert your JSON fields, which are currently CLOB, you can convert them to the native JSON data type. We also in 21 have added the ability to load from a file directly in the object store with SQL Loader. So this is, of course, very useful if you're moving flat files around, especially from other types of databases. Like we've seen this used, for example, even already going from something like Amazon Redshift, which is a non-Oracle database. If you want to dump database out there into flat files and then load them into ADW, this is a good way to do it, which is using a SQL Loader from the object store. So you would start by creating your wallet for your cloud, for your client area, wherever you have your SQL Loader client. And then your SQL Loader client can reach out to the object store on the one hand and load into the cloud on the other. So your client's local, but you're going directly from an object store into the cloud, and it's not going to have to pass through your client to do that. So those are the 21C new features. And you might notice I've only gone 25 minutes into the talk. And this is a good time to mention that we don't expect people to go to 21C for production. 21 is what we call an innovation release. It's not a long-term support release. In fact, 19C will be supported for far longer than 21. 21 only gets about 2.5 years of support. The second that 23C comes out in a couple of years, or yeah, a year and a half or so, 21 is no longer going to be supported. So most people should be going to 19C right now, and it's good to know what some of our new features in 19C data pump are, because 19C has premier support until 2024 and extended support all the way into 2027. So what's new in 19C? Well, we have a bunch of new features there. We have support for the encrypted columns clause, some controls over parallelism, explicitly enabling authenticated roles, which is a security feature, use of object store credentials, wildcards for object store data files, transportable table space test mode, and then read-only table spaces are back for transportable table spaces. So I'll go through each of those fairly quickly before I get to the super patch. So in when you're moving a database into table space encryption, one thing you can't do, if you had the older style of encryption, encrypted columns, which was introduced, I think, in 10.2. So that was before table space encryption existed. If you want to take a table that has encrypted columns and move it into an encrypted table space, that was an issue because you can't put an encrypted column in an encrypted table space. This feature in 19 lets you do that seamlessly with data pump, where we essentially emit the encryption clause on your column so that we can move it into the table space without you having to manipulate it or decrypt the column first. So that's just a helpful ease of use or quality of life improvement for migrating into TDE. In terms of parallelism, we give you the ability to control maximum resource usage of data pump at the database level. The reason we've done this, frankly, is for multi-tenant environments, especially where you might have one container database with many, many PDBs in it. And in our cloud, for example, in ADW, we will have up to 800 pluggable databases in a container. And if people are using data pump with a lot of parallelism, like you do an import with parallel 32 and then your neighbor does that as well, pretty soon that adds up to a lot of processes in use. And you may need to control that in that kind of environment. So there are these two controls that are available: maximum data pump jobs per PDB and maximum parallel per job, that you can set if you want to control the resource utilization on your systems. So whether you've got multiple users in just one non-CDB or multiple pluggable databases, you can control how many processes data pump will be allowed to spawn per job or per database. And they have pretty reasonable defaults there. 50% of sessions. I don't know many cases where you would want data pump to use more than 50% of your available sessions, for example. This is a very small feature, explicitly enabling authenticated roles. It's really just kind of a lockdown to make sure that your data pump imports are secure by default. The idea is that a dump file could have grants to authenticated secure roles in it. And if you are asked as a DBA to import a dump file for somebody, this helps make sure that that somebody has not granted themselves privileges via these authenticated roles they shouldn't have in the new database. So what it means is that if they have secure roles as part of their dump file, and remember, their dump file could come from whatever database they've created where they had full privileges. Now you're importing it into maybe a common database or a production database. You would have to explicitly say that you want to allow them to use those secure roles. So this is simply a secure by default feature. For importing into cloud, into autonomous database, we added the ability to do that in 19C. In our autonomous database, you could import from any of these cloud object stores, the AWS S3 or Azure or Oracle Cloud Object Store. Now, this capability will be coming on premises to Oracle Database. The DBMS Cloud package is present in the 1910 and later release updates, but there's a little more work for us to backport, import from the Cloud Object Store to the on-premises release for 19C. We're working on that. That will be coming sometime soon, is all I can say. So this is just an example of how to do it. I've already talked about this with the 21C slide, so I'm not going to go into detail here. These slides have a lot of hidden slides also for reference. We added the ability to put wildcards into your dump file names even when they're in the object store. This is something that's always been there for dump files on disk. The %U and %L wildcards give you system generated post fixes, or actually just values. %U will increment from 1 up to 99. So you could, if you put that in, you could have up to 99 dump files. So if you have here this example exp %u.dump, would produce up to 100 dump files if needed. %L increases that to over 2 billion dump files if needed. And the reason you would do that, first of all, is whenever you're exporting with parallelism, you want to use a wildcard so that we can create multiple dump files. That way we're writing to multiple files and we don't have contention there. And second is, especially when you're migrating over the network, it pays to keep your dump file size reasonably small, to like 5 or 10 gig, so that you can copy them easily and not worry about what happens if you're halfway through a terabyte data transfer and you lose your network connection. So you can combine this with the file size parameter. And if you'd said like file size equals 10 gig and your database is a terabyte, you're going to get a lot of dump files, 100 plus dump files maybe, and that way you would be able to create them automatically without having to list the dump files. In the transportable table space area in 19C, we added some useful features. One is what we call test mode. Now, the reason we added this is that, as I mentioned earlier, when you're doing a transportable table space export, you have to set your table spaces read-only, which is essentially an outage on a production system, right? I mean, very few production systems run with all their table spaces set to read-only. And that can make it difficult to test a transportable table space migration, and that means you won't even know how long it will take or whether your closure check is going to succeed. So the closure check part of transportable table space is to make sure that all of the objects within the table spaces, all references that they have, are contained within the set of table spaces you're moving, that you don't have any references to something in another table space that's necessary, like a partition of a table that somehow exists in another table space. So by allowing you to use test mode, what we do is we allow you to do the transportable table space export without setting your table spaces read-only. Now, this is not going to be a usable export, but what it does is it goes through the whole process of exporting the metadata so that you know how long it's going to take and that it will succeed before you actually have to do the live migration. So it's just a little bit of a tool to help you with your planning, how much of a downtime window you'll need, and to make sure that at least the export side is going to succeed. Now, if you go try to import that test mode export, you will get an error saying that this is not a valid transportable table space export for production use. Another feature introduced for data pump is, this is actually reintroducing old behavior. So before 12.2, when you perform a data pump import, we would not set the table spaces to be read-write ourselves. We would let you do that manually. You would, after the import, you would set all your table spaces read-write, and then you'd be in production. Well, starting in 12.2, for 12.201 and for 18, and for 19, by default, what happens is on the import, we actually open the table spaces read-write so that we can reclaim free space that isn't being used, and so that it allows you to go to a database that has a higher time zone version than your source database. So what'll happen, say you did your export from a database that was time zone version, say 31, which was the default, I think, for 12.2 or 18, and you import into the latest version, time zone version 36. It used to be that wouldn't be allowed before 12.2, but with 12.2 and later, we will fix up your time zone data automatically as part of the import. But in order to do that, we have to open the table spaces read-write. Well, it turns out that there were a number of customers who depended on those table spaces staying read-only for a very specific reason. And that is that if your table spaces are still read-only, they can be mounted in 2 different databases at the same time, right? So if you wanted to, you could have read-only table spaces attached with the very same file, not even just copies, to 2 different databases. And that allowed people to do things like test the import and then drop the target database and still have the databases in production on the source side. So we had a few requests for retaining that behavior, and we now allow you to do that. If you say transportable equals keep read only, then when you import, we will not open the table spaces read write, which means we will not regain free space. And it means that the target database has to have exactly the same time zone version, but it also gives you the benefit of being able to have the table spaces present in two databases at the same time. So this is a very fringe use case, but it was important to a number of customers, so we put it back in. And that's one of those cases where we miscalculated. Essentially, we were providing this new capability of regaining free space and of updating your time zone data. We didn't realize the impact it would have on customers that were using the read-only capability. So here's an example of it. If you just say transportable is keep read only, that's all you have to do. Okay, so the last few minutes here, I want to talk about a very important set of patches that we have for data pump. And one is what we call the super patch. This is informal. You're not going to find, actually, I think you might find that term in my Oracle support, but let me tell you what this is all about. So starting in 19.10, and we cannot take it earlier than that, there was a lot of work that went into this. We created a single merge patch that fixes and enhances our data pump patching process to make it faster and more robust. So just this one patch includes 19 different enhancements and fixes to make it much faster to apply data pump patches. It'll be more robust so that we end up, for example, with about 90% fewer invalid objects afterwards. And by the second time you run this, you should have 0 invalid objects, second time you patch. And this is a big win for anybody who's using data pump and applying data pump patches on their systems. So basically what it does, it's faster, has fewer invalid objects, and it creates less contention on your database just by the design of the patch and by the fact that it runs faster. And when I say faster, I mean it runs 90% faster than our previous DP load. Because what we used to do when we patched data pump is we would essentially rebuild all of the packages that are associated with data pump and with the metadata API. So it's the DBMS metadata package, DBMS data pump, the PL SQL packages for the worker, the control process, and so on. Now it's very targeted, and it also has a lot of optimizations to make all of that run much faster. So how do you get it? Here's the patch ID. The current patch ID that you would want would be 329.19937. And this is available for 19.10. I'm going to tell you a better way to get this in a moment, though. So if you get this, you can install this on any database. In fact, you can install it even while a database is running, because all that patch does is it takes these scripts that are used for patching data pump and it puts them in your Oracle home. So this particular patch doesn't do anything to your database. It just gets it ready, gets your Oracle home ready for the next time you patch data pump, and it makes it faster. So even on a running database, it will not affect your database at all. And as we say, we intend to include this in a future release update. Now, on top of that, we have what we call now a data pump merge patch on top of the 19.12 and the very newest 19.13 release update. Now, 19.13 came out just this week. It came out on Tuesday on Linux. It's going to be coming up, I think, in a week or two on Windows and so on. But this merge patch includes all of those patching improvements, plus much more. And you see the list of bugs fixed in the 19.13 merge patch on there. So how did we determine what to put into this big data pump merge patch, or you think of it as a data pump bundle? What we did was we looked into Oracle support and we found all of the most requested fixes for Oracle Data Pump. So we looked at the SR counts and how many times people had requested a backport of a specific patch, and we put the most requested ones into this merge patch. So this, the current one you see there, 334227777, that was for the release update that came out on Tuesday of this week. We also have one for 19.12 that has slightly fewer fixes in it. And what will happen is that this merge patch will be enhanced with each release update. There will be a data pump merge patch. So the advantage here is that if you get this merge patch, it's already been tested on top of the release update. So there won't be any conflicts there. It is built and to be available when the release update ships, to be tested with the release update with no conflicts, and to have all of these important fixes in it. And you'll notice that one of the fixes in here, the second from the bottom, is the super patch that makes applying this patch so much faster. So this is our attempt to make it much easier to patch Data Pump and to get you the fixes in one nice package so that you don't have to request them individually, get a new update every time you get a release update. You can just download the new Data Pump bundle and it should deal with your performance or correctness issues. Last thing I'll mention is just where to get information. If you haven't heard, I'm sure many of you have been in our seminars that we've done. Mike Dietrich, Daniel Overby Hansen, myself have recorded a set of 9, actually it's now 10 webinars. Our most recent one was just yesterday, actually, on how to get minimal downtime for your database upgrade, including zero downtime approaches. So if you go to the upgrade blog at MikeDietrichDE.com under videos, you'll find our entire web seminar list there. Now it's up to 10, and we have more seminars coming up. Our one in November is going to be on fallback strategies. And then in December, we talk about how to migrate very large, more than 110 or 100 terabyte databases. We'll talk about how to do that in a timely manner. And then in January, we'll take a very deep dive into Data Pump internals, little known features and all that kind of stuff, not just new features like this, but we'll do a very deep Data Pump dive in January. All of these webinars are available for free on demand, and you can get the location from Mike's blog. And we also have our YouTube channel that you might want to check out. The title of it is Oracle Database Upgrades and Migrations. And what we've done there is we've got some specific videos that we produce for that channel. And we also take our webinars and we break them into bite-sized chunks of 3 to 8 minutes on specific topics. So while a webinar episode might be 2 hours in length, and you may not have 2 hours to deal with, or to watch something, if you go to the YouTube channel, there will be specific things, everything from how to do online table space encryption to the basics of auto upgrade and so on. So with that, I'll just put up the location of our 2 main upgrade blogs, which is Mike's blog, Daniel's blog. I will mention that we also have now Rodrigo Jorge, who joined us in June, and he has a blog as well. We'll be adding him to our slides, and he's also been part of our latest webinar recordings. And I will go look at chat and Q&A to see what we have there, because I'm now at exactly time. Cool, finished on time. Okay, so first of all, in the chat, let's see if that was a question or not. So question or not. No, okay, so that's just chat. Okay, will the super patch be available for the Windows platform? That's a really good question. So the great thing about the super patch, the super patch and the merge patch are both SQL, and that means that they are generic platform. So they will run on any platform. You don't have to get a platform specific version of them. Because the super patch itself, it's all about the dpload.sql script. That's how it gets applied. And the merge patch all of those patches are limited. We don't put anything there that requires a shutdown of the database. So even that merge patch can be applied to even a running database as long as you're not using data pump. You might want to have a maintenance window for that because you may not know who's using data pump, but both of those are platform generic because they're only SQL and PL SQL. Now, the wrinkle for Windows can be that sometimes patches don't show up as available on Windows, and that's actually something I'm working on right now with our patching production groups, because those of you who use Windows already know that it can be difficult to find or to get a one-off patch on Windows. If you ask for it, the process seems a little murky, and we just went through the process of producing another merge patch on Windows this week, so I'm working on that. The answer is yes, it will be available, and I'm trying to make that process easier really as we speak. We're trying to get it documented as to how to make sure that a generic patch is available on Windows. So let's see, any other questions about data pump functionality or about the super patch or other new features? Or if you want, I could actually take time and go back to some of the other new features from earlier versions, especially if anyone wants to hear about how parallel metadata works. I always like to go over that. Okay, so.
No question, but
no
sometimes people need a bit of time to write it down.
Yeah. So,
but of course, you can take your time, and if you want to add something on one of your previous slides,
yes,
please go.
Let me do that. So
yes, let me go back
so you can see, yes, by the way, that I have a lot of hidden slides here. This is all the 12.2 features, such as long identifiers and so on. But what I really want to talk about is parallel export and import of metadata. So this went in 12.2. So if you've only used 12.102, 11.204, you haven't experienced this yet. So in 12.2, we added parallel export and import of metadata, not just data, for dump file migrations. And as you saw earlier, we now have this for transportable table space jobs as well. Well, in 12.2, we added export and import. And what we will do is for data, of course, we export using one worker per subpartition, per small table per partition. And now in 12.2, we can use those same worker processes for metadata. So this is how it will look different in your log files. In 12.102, what you would see is you'd see the estimate phase going, we do all of our metadata, and then when we got to the table data section of the export, we would start up all the other workers. Now in 12.2, we start up all the workers up front, and you'll see some examples in this log file here, for example, how we process roles and over using different workers. You can see the W hyphen there. That's the worker number that's used to process, for example, profiles, users, and roles kind of successively. So this parallel metadata import is also available in 12.2, and it does not require a parallel export to use parallel metadata import. So in 12.2, what we do is we import most metadata in parallel as long as there's not dependency ordering needed. And the types of metadata that require dependency ordering are things like types, because we have type evolution. Different versions of a type have to be imported in order. We have schemas because schemas do have dependencies between them. And then the procedural actions that are part of importing certain types like OLAP and scheduler jobs and so on have to be done in serially. So some details here. The metadata is exported in XML documents. So when the metadata for data pump goes into these XML documents, and each XML document has a certain number of entries for a particular type. So for example, for users, we put 80 users, up to 80 users in each XML document. And that means that if you have more than that, you'll have multiple XML documents stored in the dump file, and we parcel those out to the import workers. So the example here, we have 161 users to import. That means that we would have, one worker doing the first 80, then another worker doing the next 80, and another one just handles one. So we take an XML document of 80 workers and tell worker 1, go import these users, worker 2, import these users, and so on. So that gives us parallelism for within a particular object type. So the comparison here, let's look at what happens with grants. You have a lot of grants in this database, over 27,000. A typical e-business suite database has hundreds of thousands of grants in it. If we are in 12.102, we import those grants in 50 seconds, which is pretty good on a per grant basis. But with parallelism, just going to 12.201, we can spread that across a number of workers. And as you see, we're importing 5 times faster. So 5 times faster for parallel 8. It's not linear scaling, but it's pretty good, right? It helps you take advantage of machine resources. And here's a more detailed look at what parallel metadata import will do for you. This was on an e-business suite test database that we have. It's about 250 gigabytes overall size, but you see the count column, how many of each type of metadata is present in an e-business suite database. While it had those 27,000 some odd object grants, look at the table grants, for example, 358,000 grants for tables, 53,000 packages, and so on. And you can see the effect of parallelism when you get to 12.201, parallel 8, for example. Let's look at rows like tables. Now that's table definitions, not table data. We already did table data parallel, but with parallel 8, your table definitions go from taking 923 seconds, so 15 minutes, down to 368 seconds, so about 5 minutes. And then you can increase the parallel to 32 and get a little bit more out of it. And you'll also notice for the truth in advertising part, some of these things do not get any better with parallelism, like types. As we said, types have to be handled by a single worker because of ordering. Some types, grants don't scale as well as you might think, because even with parallelism, every time you create a grant, there's a hard connect involved. And then package bodies, we've done package bodies in parallel even since 11.2, but as you can see, there is some improvement the more parallel you go. So we find that parallel metadata is a huge win for customers going to 12.2 and later. So if you've never had this with 11.204 and 12.102, if you import in 19C, you're going to get advantage of that, even if you don't export with parallelism. So let's see, I'll just point folks to the chat saying that Fernando has put some more information there about the last topic that was discussed in his talk. And this point, we're at 9:55. So if there are no other questions, I'm comfortable ending it here. What I will do is I'll just put up the last slide in our deck, which is the location of the upgrade blogs here. This is where you'll be able to download this and all of our other information. We have our comprehensive slide decks, links to videos, and so on. So I hope this was useful to everybody, and hope you enjoy the rest of the day and Jim Zabrinsky's talk.